দেওয়ান স্যার আসছেন? হ্যালো দেওয়ান স্যার, আমাকে শুনতে পাচ্ছেন?
হ্যাঁ শুনতে পাচ্ছি আপু স্যার।
আপনার তো সব মিলে 7 জন স্টুডেন্ট এখনো পর্যন্ত আসছে।
সবাই আস্তে আস্তে আসে, দেখি ওয়েট করি। আমরা গত ক্লাসেও একই অবস্থা ছিল, আসতে দেরি হয়েছিল আর কি।
আচ্ছা,
একটু ওয়েট করে দেখি।
হ্যাঁ এক্স্যাক্টলি 11টার সময় আমি শুরু করি।
আচ্ছা আপনি শুরু করেন, আস্তে আস্তে ছেলেরা আসে আর কি, দেখি।
2582
Okay, students, turn off your microphone, please. We will start from now. Our class will start from now. Okay, dear student, Assalamu alaikum. I am your subject teacher of physics. And after a lot of days, we are back to our lecture, our college lecture, in fact. So, first of all, welcome. And again, we will discuss today about current electricity, the new chapter, which was on your syllabus of first year. This chapter includes a lot of topics, but some topics you have read, you have studied on your class SSC exam or class 10. So those topics we are going to ignore first because we know these topics very well. Such as, if we talk about current electricity, we know about Ohm's law. What we have discussed previously on class 10. Ohm's law, first one is Ohm's law. Then second law, resistance law. Then the third one, combination of resistance. Then number 4, Ohm circuit. So if we look into this topic, all of these topics we have discussed when we were in class 10. These topics are not important for this class because those are important for class 10. So here we will discuss some new topics in this chapter. And what are the new topics? Today we will discuss some of it, such as drift velocity, then Wheatstone bridge, then Kirchhoff's law. So if we look into these topics, and there are a lot of some topics are also available in current electricity chapter, we can see that the last topics we didn't study in class 10. So these topics are more important to us for this class. Okay? So first, we will start from current electricity. So we have to know one definition first. What is current? What is current? This is the first definition for current electricity. Everybody knows it. What is current? So first, we will write the definition of current. Okay? So I am telling you the definition. You just write it. Current. Because when charge flows through a conductor per unit time is called current. When charge flows through a conductor per unit time, is called current. So you can say from the definition of current can be said as charge per unit time, or you can say it as Q by T. This is the equation for current. We knew that equation, and here what is the unit of current?
Coulomb per second.
The unit of charge is coulomb and time is second, so it's coulomb per second, right? And also coulomb per second can
Ampere.
be said as ampere. So you can say that the unit of current is ampere. Okay, good. Now, on the current electricity chapter, we will discuss about some topic which is not included on your textbook of class 10. But current is also included with this topic. This topic is drift velocity, the first unknown topic of current electricity. Drift velocity. So what do you mean by drift velocity? If we talk about the potential energy when the potential energy is higher, the velocity of an object will be greater. And when the potential energy is lower, if it is released, then its velocity will be lower. So if we talk about the drift velocity of current, drift velocity of charge, then we can say that it is also depends on potential. But it's the potential difference, that means the voltage. So we can say that when the voltage is greater, then the velocity of charge through a conductor is greater. And at that time, that velocity of the charge is called drift velocity. So if we write the definition of drift velocity, then it can be said like this. So write the definition. The velocity of charge, on a conductor. Everybody should write this. The velocity of charge on the conductor due to the difference, potential difference, in fact, due to the potential difference between the two ends of it. The potential difference between the two ends of it is called drift velocity V. You should write small v. The drift velocity V. Okay, so when we have a potential difference, the charge has different velocity. If we have larger potential difference on wire, then the charge will get larger velocity. That velocity is drift velocity. So now, if we say the function of drift velocity, the equation, if we want to get the equation for drift velocity, we will draw a figure like this, where we say that L is the length of wire, A is the area of cross section, if we say that these are the electrons, goes with the drift velocity V. So small v is the drift velocity. And if we say that the charge of electron, E, is the charge of electron. So another thing we have to denote here, I am giving a symbol here, N. N is the number of electrons per unit volume. Number of electrons per unit volume. So these are the quantities when we want to get the equation for drift velocity. L is the length of wire, A is the area of cross section, V is the drift velocity, charge of electron is E, and N is the number of electrons per unit volume. Okay? Now, if I want to get the volume of this wire, then what will be the volume of wire? Volume of wire should be A into L. So you can say it as AL. The volume of wire can be said as here AL. Now, if I say number of electrons per unit volume is N, so if I write in this way, number of electrons per unit volume is N, so number of electrons per AL volume, because we have AL volume, then it will be NAL. So it will be NaL. Here on the conductor, or you can say in the wire, the number of total electrons in this wire is NaL. Okay. Now, if I say each electron has charge of E. Here, each electron has charge of E. So, what will be the total electron charge? Na electron has charge of NaLe. So here I get the total charge of this conductor, and that is NaLe. These are some mathematical expressions in a wire. So the total charge in a wire is NaLe. Okay, but we are going for drift velocity, and we have equation of total charge. So first, we know that what is current. The first definition of this chapter, what is current? So we have current as, but we know that current has the equation of Q by T. So here Q is the charge, the total charge. Which one? This one. So I can say the total charge is NaLe, so the total charge is Q. So I can say NaLe by T. This is the current equation. I is equal to Q by T, on which we can say that NaLe by T. Okay, so how we can make drift velocity from this equation? Just like this. If you see this L by T ratio, L is the length, length means distance, and T is the time. So distance by time can be said as velocity. And you have to remember one thing, that when charge flows through a conductor, it has no acceleration. It only goes with uniform velocity. So what is the definition of uniform velocity? Total distance divided by its total time. So we can say that distance divided by time can be said as V, and that V is the drift velocity. So finally, I can say NaVe is the required expression for current, from which we get another equation for drift velocity, just as I by NaE. So this is the drift velocity equation. In such a way, we can get the drift velocity as well as the total current of a conductor. Okay, so now we have an equation on the board. So I will give you a mathematical problem, and you will give me the answer. Okay, start. The mathematical problem. Everybody should write. Okay. The number of electrons per unit volume of a wire is, the number of electrons per unit volume of a wire is 10 to the power 14. 10 to the power 14. And the area of cross section, of the wire is 5 centimeters square, and the area of cross section for the wire is 5 centimeters square. Full stop. Then what will be the flow of current on that conductor what will be the flow of current on that conductor if the drift velocity of charge is 20,000 kilometer per second. If the drift velocity of charge is 20,000 kilometer per second. It's kilometer per second, so you should
0.16.
0.16. Okay, very good. And I will take some time because others are doing this. 0.16 is the answer. Okay, I'm just taking some time. For the rest of Okay, one of us told that it's the answer of 0.16.
Yes, sir. The answer is 0.16.
Okay, so the answer is 0.16. It is the right answer. In fact, the answer is 0.16 ampere. So the current flows through that conductor is 0.16 ampere. Okay, so here one information is not given to you, and that is the value of E. But we know that the electron charge is 1.6 10 to the power minus 19 coulomb. So that's why if I place all of this value in equation, I can easily get the current of the conductor, and that is 0.16 ampere. Okay, good. So this is one mathematical problem for drift velocity. And now we'll go for another topic. It's the important one, but uncommon. That is combinations of cells. Combinations of cells. Okay, so on SSC, during the time of our SSC, we had learned about the combination of resistance. When we completed the electrostatic chapter, at that time, we had learned about the combinations of capacitors. But this time, we will discuss about the new one, combinations of cells. So how a cell can be combined in a circuit? Two ways. One is the series combination, and another one is the parallel combination. So there is nothing different. The main two way of combination for any electrical component into a circuit is series and parallel. Now, first we will discuss about the series combination of cells, from which we can understand what will be the value of current flows through a circuit when we combine the cells in series combination. Okay, first I am drawing the diagram for series combination of cells. So here is the diagram. I'm just giving an external resistance here and a lot of cells in series combination, just like this. It's a simple circuit, but I am using n number of cells here.
Abusa, shut your mic.
Okay, I'm just recovered the blur position. Just give me some time.
স্যার ফোকাস লক করে দেন।
Focus lock হচ্ছে না এখানে। আচ্ছা, anyway, that should not be a problem. It will be recovered soon. Okay, I'm giving you the statement of this combination, and at that time, okay, now the board is clear. Okay, let us consider, all of us should write this. Let us consider n number of cells are connected in series combination. N number of cells are connected in series combination. In series combination, in which each cell contains electromotive force of capital E. Each cell contains electromotive force of capital E and internal resistance of small r, and internal resistance of small r, and internal resistance of small r. So here each cell contains the electromotive force of E, and each resistance contains the internal resistance of small r. Okay, so how we can describe it? When we combine n number of cells in the series combination, then what will be the total electromotive force or total EMF? You can say it as EMF, the short one. The total EMF, suppose it's E bar, as E plus E plus E plus, you can say n number of cells, but n number, you can say this n number. So all of these cells are connected in series combination. The total EMF should be E bar as NE. So this is the total EMF in this circuit. E bar is NE. Again, if I want to get the total internal resistance, all these resistors are connected in series. So what will be the series combination for resistance? That is RS, which is R plus R plus R. You can say it as N number. N number of internal resistance are connected in series. So the total internal resistance should be N small r. So this is equation 1 and this is equation 2. So we determine the total EMF as well as the total internal resistance from here. But what is the current equation? The current equation we can say in this way: I as E by R plus R. This is the general equation for current. When you solve the current circuit on the textbook of class 10 on your SSC exam, that is the equation you have written several times. So if I say for this, E becomes E bar, because I am giving the total EMF as E bar. And also the internal resistance, I am getting RS here. So the equation for now, it becomes E bar by R plus RS. And now if I plot this 1 and 2 in this equation, E bar becomes NE from equation 1 and RS becomes NR from equation 2. So finally, I can get the current as just like this, R plus NR. So this is the combination of cells in series, and I am getting the equation of current from this combination of cells. You see, I have discussed the total class about the current, the topics of current, and we will get some equations of current as well. This is the combination of cells for series. Now we will discuss about the parallel combination. So I'm now drawing the parallel combination. So it's parallel combination for now. Just like this. So this is the parallel combination on which I am drawing all the electromotive force or the batteries in or the cells in parallel combination. So this is the diagram. So first, you should draw it. The diagram of parallel combination of cells. Okay, so we should start. We should write the statement, and the statement is, let us consider n number of cells are connected in parallel combination. N number of cells are connected in parallel combination on which each cell contains electromotive force of E by EMF of E. That should be that will be good enough. Each cell contains EMF of capital E and internal resistance of small r and internal resistance of small r. Full stop. Now you have to write a sentence, and I will explain you later. In parallel combination, one of the total cells is active during flowing current. Okay, I will repeat the sentence again. In parallel combination, one of the total cells is active during flowing current through the circuit. One of the total cells is active during flowing current through the circuit. So the total EMF for the circuit will be equal to the EMF of one cell only. So the total EMF of the circuit, will be equal to one electromotive force by one EMF of a cell, by EMF of one cell. That will be the correct one. EMF of one cell. So total EMF here, I can say that E bar is E. Now I can explain to you. When you are giving a combination of parallel in such a way that all of these electromotive force are equal and they are connected in parallel combination, at that time, for equal EMF and equal resistance, only one cell will be acting for flowing current through the circuit. Only one. And the rest of the cells, we can say that the rest of the cells will be deactivated at that time. When first cell is discharged, then the other cell will work. In such a way, in parallel combination, cells are working. One cell will act and the rest of the cell will just stop. They will not flow any current through it. So the total EMF, E bar, can be said as the EMF of only one cell, and that is only E. But if we talk about the total resistance, all of the internal resistance are connected in parallel due to this combination. So what is the parallel combination for resistance? It's 1 by R1 plus 1 by R2 plus 1 by R3, just like n number of cells. So you can say 1 by Rp as n by R, or finally Rp can be said as R by n. So this is the internal resistance for this combination. And the total EMF also we have got as E bar as E. So what will be the current for this combination? I can say it's just like this. E bar by R plus Rp. Rp is the internal resistance and E bar is the EMF of the circuit. So here E bar can be said as only E and Rp is R by N. So we can say further E by R plus R by N. And if I got LCM from here, I can say NR plus small r by E. So finally, I can say I as NE by NR
plus
small r. So this is the parallel combination, and I'm writing the series in the right side. This is what you have got for the series combination, and look, these two equations looks like the same. Sometimes we are confused on it, but there is a slightly difference. One is NR, N capital R plus R, which one is the bottom equation, and the right one, R plus NR. So the current will be different for these two combinations. Definitely the current will not be the same. Okay.
Sir, this is one for parallel.
The bottom one is for parallel and the right one is for series.
Okay, sir.
Okay. So
Yes,
boys, I will give you another math for this. Using these two equations, you will get the value of current, and this will be the end of our class for now. And after that, we will return to 12 p.m. again, and we will discuss the next part. So I am giving you the math, and then we will stop this class. Okay. First, write down the math. 10 cells. 10 cells are connected in. 10 cells are connected in series and parallel combination. Series and in parallel combination, on which each cell has EMF of 2 volts, on which each cell has EMF of 2 volts and internal energy of 0.5 ohm and internal resistance of 0.5 ohm. Full stop. What will be the flow of current for 20 ohm external resistance? What will be the flow of current for 20 ohm external resistance? 20 ohm external resistance. So you are given the number of cells, you are given the electromotive force, you are also given the external resistance, which is capital R, and the
সিরিজে
small r
0.8
also. Series A,
0.8 আসে আর ইয়াতে প্যারালাল আছে 0.099
okay, good, very good. You are doing very fast, but we have to take some time. We have to give some time to others because also we need, everybody should do this math. Okay, I'm taking your answers.
আব্দুল্লাহ আরেকবার বলিস।
For series, it's 0.8 ampere. And for parallel, it's 0.099, right? Is it the parallel answer?
জি স্যার
0.99 এর
0.099.
ক্ষেত্রে কি 1 দিতে পারবো?
You can say it as 0.01. 099 or 0.1, right? 0.099. So you can say that 0.1. Okay, that will be good. 0.1 ampere. And the another one is 0.8 ampere. So when we combine the cells in series, we will get much current than the combination in parallel. Because parallel, we know that only one cell will be activated and the rest of the cell just like stop or deactivate. So that's why the current flow on the cell when combination in parallel, the current flow is less than the series combination. Okay, so boys, we have done one of our class and we will go for next class at 12 p.m. You have times of 20 minutes, just like the tiffin time. Okay, thank you, boys. I am
আসসালামু
now
আলাইকুম স্যার
closing the. Okay, thank you.
আসসালামু আলাইকুম স্যার
Assalamualaikum.
Allah Hafiz.
স্যার।
আসসালামু আলাইকুম স্যার
Salam.